Okay, Bismillah Rahman Rahim. Dear students, as my father is not well, I have to go for the MRI scan and all, so I can't come to the college, but the classes will not stop. That's what my promise was all the time. So I'm trying to find some time after Fajr prayers to just make a video and just upload that for you guys. Okay, so here is today is actually 3rd March 3rd April, sorry, and 2021. So it's a lecture for the 3rd April 2021. So we are moving from 2D to 3D actually. Okay. So now we have a 3 dimensions. We have done the 2 dimensions. It's pipeline. We've seen how the from the object in the real world we get that into the onto the screen, how we do all those things. That pipeline we have seen, the 2D pipeline. The 3D pipeline is kind of same, okay, but with the difference. In overall, we have say for example some real world object, and we need to model it, okay, and then we need to render it and to put it on a screen. Okay, if you want to put it on a screen in totality, if we don't go in depth, in overall we say you got to model it and you got to render it. Then rendering will be in accordance to the screen, how you actually put those pixels and all. Then all those graphics drivers and your graphics processor will be doing all those things. But when we have a 3D now object, okay, if we have a 3D object and you want to put it on the screen, as you could see, I'm making this some kind of a cube. It doesn't look like a cube because all these squares should be same. Imagine this is a cube or cuboid or whatever you say. uh, but if you see, I am just plotting it in two-dimensional space. So my screen is just a two-dimensional. In a real world, if we have a lenses or we have an eye, that's kind of a spherical, that's a curved surface, not a plane surface. But usually our screens, they are plane, okay, they are just the 2D. So even though you are making a 3D pictures, you are making them on a 2D. That's in a what's called the viewing plane. It is a plane. When you say plane, it means 2 dimensions, where there is length and where we have a breadth, and there is no depth. So that means in totality, actually the depth we have in our 3D, that's gone. We can't have it. So we need to do some kind of projection, okay, uh, so that we can show the information of a 3D object on a 2D space, right? So when you view an object in the spatial position, you may be in front of the object, you may be behind the object, okay, you may be in the middle of the group of objects, you can be inside the objects, and your viewing can be either straight way, you can watch it obliquely, okay, you can watch it at any angle you like to, top, front, bottom. So there could be many scenarios where we just want to have a 3D, because basically the whole thing will be to plot a 3D object on a 2D viewing space, right? Because our viewing space is just 2D. So this is kind of done using the viewing pipeline in totality. It's called the viewing pipeline, okay? So in general, if you have some kind of a 3D object, right, and you want to put it on a screen, then you need some kind of a device which will capture it. For example, our eye, okay, which has its own coordinate system, or we have a camera which can get it. So we need some kind of a modeling, because this house is bigger, huge. So you have to put it on a screen which is very smaller. So you need some kind of what's called as a modeling transformation. You have to model so that this can be captured in a piece on a small space, right? Like we were talking about the 2D models, that you have a mountain, Hari Parvat, we were last time talking about. It's maybe in kilometers, but your photograph is just small. So you need some kind of mathematical modeling to get it into that space. So you have the modeling coordinates. right? You have a modeling coordinates which will be like kilometers was converted into the centimeters or millimeters or whatever. Okay, then you need to talk about the world coordinates. Then from the world coordinates, you need to have a kind of a weaving transformation. Okay, because now uh, we have what is the weaving coordinates, which these coordinates should fit in. And then you maybe you need to then project it on the screen. Then you need a projection transformation, where in transformation we know we can scale it down, we can rotate it, we can do a lot of things to it. Okay, to get it onto the projection plane. So in simple terms, we say that we have a 3D object. Okay, and the 3D object is models. We need some kind of mathematical modeling transformations which will have the world coordinates with it, but we need to convert that into the weaving transformations, because now the weaving transformation will have the weaving coordinates. Because why we have what is weaving transformation is, for example, this is a cup. If you see it from this way, it will look like this. If you see it that way, it may have the handle with it. If you see this way, it will be only handle and that side of the cup. So that means weaving coordinates will be different. Okay, now you have what kind of side are you seeing the picture, from the top or bottom or left or right, whatever you are seeing, you take those coordinates. Okay, and then you need to do the projection transformation, where you will do what in projection transformation. What you will do, you will just simply you do all the transformation we have done. Like you try to clip. Okay, you will see what's the visual surface identification, and then surface rendering, where you will do shadings and all to those and all. Then workstation transformation is that you just want, now like we had a rendering in case of 2D, we said that now you want to put it on a display device. So you need a device coordinates on that, the screen coordinates on that. So this is overall what is called as the viewing pipeline. Okay, this workstation transformation is also called as viewport transformation. If we see just the simplest example of projection, where we are trying to lose the depth actually, right? Because we don't have the z here, which is the depth. Okay, so in my this is just a line, or it could be a 3D object which has x, y, and z. What we do is we have the x is this way and y is this way. Parallel to this we make our weaving plane. Okay, parallel to this. Okay, and our z goes like this. Now our z goes like this, which is the 0 in it, because it's like you put up a copy here on this line and put this line through the center of the copy. So that will be parallel like this. And what is outside of the copy and what's inside of the copy, that is your z, which has got to be 0, because we don't have the depth on the plane, right? Now we talk about the actual topic, that is the projections. So the projection is what you are having a 3D and you are trying to project it on a 2D space. So how we do it now? Okay, so there are basically two types of projection. So as a definition, it's a process of transforming 3D coordinates of a shape to the points on a weaving plane, and the weaving plane we know is a 2D surface. Okay, so either we have what's called as a perspective projection, or we have parallel. So there are two types of projections, perspective and parallel, and then there are many subtypes. So these are the types of projection. So either in it's a parallel or it's a perspective. Okay, when parallel there are the parallel lines, and perspective we converge to a point, we'll discuss that. And in parallel we got the orthographic or oblique, and in orthography we can have a multi-view or axonometric. which is itself isometric or dimetric or trimetric. And in oblique we got general, we got cavalier or cabinar, and in perspective we got 1 point, 2 point, or 3 point. Now we need to discuss them one on one, right? So in the uh, parallel projection, uh, we have the parallel lines, okay, to the weaving plane, and in the perspective projection we got the convergence, and they will move on to the point. What does that mean is like this. If you could see, this is the perspective projection, but this is my object, for example AB, and this is the projection plane, and these are the projectors or the lines, the rays of uh, the light which actually projects, which emerges from the that object. And if they converge, they are coming, not in parallel, but they are coming because they're the lines which come from the AB on the projection plane are thousands of lines and many many lines, and some of them are parallel, some of them are oblique. So those lines which meet behind this projection plane, which is called the center of projection, so these projectors, if they converge, these kind of projection is called perspective projection. Instead of it, if we have the lines which are coming parallel, okay, so they are going to meet at the infinity, uh, these uh, these projectors. So this what's called the center of projection will be at infinity if the lines are parallel. So this kind of projection is called as the parallel projection. This is just another copy of it, so you can put up these small points which we will discuss later also. So, and just have a just copy this for the exam purposes. Now the broad difference between perspective versus parallel is, perspective which converges, it's like a human eye, wherein we see the what's called as the foreshortening. In foreshortening, we have, if it is a object is far away, it looks smaller. If the same object is closer, it looks bigger. Okay, but in the parallel, it preserves relative proportion. This foreshortening, that means the bigger and smaller, because the distance, that's the depth, is not in the parallel perspective, but in the in the parallel projection. In the perspective projection, it works kind of like our